All right, let's dive right into this explainer. We're unpacking the massive macroeconomic and geopolitical realities driving the global shift to electric vehicles. Because trust me, this is way more than just a story about cars. We're talking about global power, major economic trade-offs, and an energy system undergoing a massive, literal system shock. Here's our roadmap for today. We'll hit the oil price catalyst, unpack this complex systems change, look at the very real roadblocks and resource risks, map out the global winners and losers, dive into something called the rebound effect, and finally ask, is this transition truly unstoppable? Kicking things off with part one, the oil price catalyst. Let's talk about geopolitics and that very real pain at the pump. So here's the billion-dollar question everyone's asking. Are we just watching an unstoppable technological evolution? Or are we all just reacting to the sheer pain of high energy prices? You know, with geopolitical tensions, especially in the Middle East, constantly disrupting global energy markets, that instability hits us directly in the wallet. It changes how we think and definitely how we spend. It's wild how directly international conflict translates into skyrocketing fuel costs, which then kicks EV adoption into overdrive. Think about it. If a major supply route, like the Strait of Hormuz, closes, a staggering 15 million barrels of oil a day are suddenly at risk. 15 million. Analysts at Wood Mackenzie have pointed out that while Brent crude futures have been hovering past the $120 mark, extreme scenarios could actually push prices up to $150 or even $200 a barrel. And consumers, they're already reacting. Take Southeast Asia, a region super dependent on energy imports. That squeeze at the pump is driving explosive change. Vietnamese EV maker VinFast literally saw their sales surge by 127% in just 1 month, year over year. People are looking for an out. Energy experts really hit the nail on the head here. Rising oil prices and supply disruptions are often the first triggers of a crisis, sparking the question of whether the future of transport is electric. Pain at the pump is quite literally forcing a behavioral shift. EV demand doesn't just exist in a vacuum, right? It's completely chained to the crazy volatility of fossil fuels. Every single time there's a crisis, the idea of owning a car that doesn't need a drop of imported oil just looks better and better. Moving on to part two. A complex system change. This goes way beyond a simple engine swap. Here is something absolutely crucial to wrap our heads around. We aren't just taking out a gas engine and dropping in a battery. We're completely ditching a system built on resource extraction, pulling oil out of the dirt and shipping it across the oceans. Instead, we're shifting to an electrified system that's constrained by infrastructure, smart grids, and high-tech networks. It's a whole new ballgame. A networked system needs charging stations, massive grid capacity, and digital platforms all talking to each other flawlessly. Because of all that heavy complexity, this transition definitely won't just run on autopilot. Researchers tell us we aren't looking at one giant global tipping point, but actually a bunch of regional transitions happening at totally different speeds. It relies on a classic feedback loop. Even with high upfront costs, when the total cost of ownership drops, more people jump in and buy an EV. That creates a network effect, driving more charging infrastructure, which then makes buying an EV even more of a no-brainer. Throw in some insane tech innovation like BYD announcing they can charge a battery from 10 to 70% in just 5 minutes, and boom, you've got the perfect recipe for rapid acceleration. All right, part three, roadblocks and resource risks. We've got to look at the industry pushback. To really get the full picture, we have to look impartially at the very real hurdles experts and lawmakers are raising. Take recent U.S. House testimony, for instance. Critics are warning that forcing this transition too fast could put unprecedented strain on our power grids. To avoid rolling blackouts, the U.S. grid would literally need to more than double its electricity supply by 2050 and build 75,000 miles of new power lines by 2035. That's massive. Plus, there's the argument about life cycle emissions. Some say focusing only on tailpipe emissions creates a systemic bias against liquid fuels, totally ignoring the heavy carbon footprint of manufacturing those giant EV batteries. And then, well, there's the critical minerals problem. But actually, before we dig into the minerals, let's talk about the giant elephant in the room for everyday consumers: $14,000. According to Kelley Blue Book, that is the current price premium of an average EV over a standard, non-luxury gas car. No matter how much you might save on gas in the long run or how great it is for the environment, that massive upfront cost is a massive, sometimes totally insurmountable hurdle for a normal family. It's a real barrier to entry. Okay, back to those minerals. Geopolitically, this shift could mean trading our reliance on Middle Eastern oil for a reliance on Chinese critical minerals. That is a completely new national security puzzle. Lawmakers are pointing out that China totally dominates the global battery supply chain right now. They control about 75% of all battery cell manufacturing and are expected to control half of all global cobalt production. For Western nations, this raises a very real, very valid concern. Are we just swapping one deep foreign dependency for another? Which brings us to part 4, global winners and losers. Let's map out the macroeconomic impact. According to the Bank for International Settlements, this energy transition is going to trigger a massive redistribution of global wealth. It's essentially going to penalize fossil fuel exporters. Their export and fiscal revenues will be severely eroded, forcing them to basically invent entirely new economic growth models. On the flip side, fossil fuel importers become the big winners. They'll benefit from cheaper, cleaner, locally sourced energy and see huge improvements in their trade balances. But the biggest winners of all, the amplified winners, are the mineral producers. Countries sitting on vast reserves of copper, lithium, and rare earths are looking at a massive structural explosion in demand. Now for part 5, the rebound effect. Let's talk about the hidden trade-offs of efficiency. There's a fascinating, kind of hidden economic trade-off to all this new efficiency known as the rebound effect. It's an economic phenomenon where energy efficiency gains actually lead to increased overall energy use because the money saved ends up stimulating more economic activity. Think about it. When EVs make driving cheaper, people and businesses save cash. That's great, right? Well, economically, yes, but environmental models show consumers take those savings and spend them somewhere else, maybe taking an extra flight for a vacation or buying more manufactured goods, which ironically drives up total energy consumption. To put that into perspective, let's look at the UK as a case study. Researchers used a massive economic model called Marco UK and found that the EV transition is actually an incredibly powerful economic stimulus. Shifting away from gas cars could unlock an extra 0.5% of annual GDP growth for the UK, bumping the baseline projection from 1.71% up to 2.25%. That extra growth comes directly from the efficiency gains of this new energy system. But here's the catch, and it's a big one. That extra growth comes at a staggering cost to our climate goals. The long-term economy-wide rebound effect is estimated at 76%. No way, right? It means that because of all that newly stimulated economic activity, the actual climate and energy savings from switching to EVs will be massively lower than we initially hoped. We're only actually realizing about 24% of the expected energy reduction. It is a profound, incredibly tricky trade-off between growing the economy and deeply cutting energy use. Finally, part 6, an unstoppable transition. Let's chart the future. So, bringing all these tangled threads together, where does this leave us? Well, if the world is to meet the climate targets of the Paris Agreement, whether that's the 1.5-degree or 2-degree scenario, battery electric vehicles simply must become the overwhelmingly dominant share of the global vehicle fleet by 2050. That is the projected reality we are hurtling toward, despite the monumental infrastructural, financial, and geopolitical roadblocks we've talked about today. Ultimately, the EV revolution is an absolute systemic overhaul. High oil prices definitely lit the match, but to keep the fire going, we literally have to build a new world from the ground up. And that leaves us with one critical question to think about. As we accelerate away from fossil fuels, are our policies, our power grids, and our supply chains truly ready for the incredibly complex, resource-constrained world this transition is creating? Thanks for joining me for this explainer, and keep questioning the systems that power our world.